chat box. Let me know in the chat box if my screen is visible and I'm audible to you. Everyone, let me know if the screen is visible to you and I'm audible to you. I'll just check your responses here. Got it, everyone. I got you. So everyone who is responding now, and everyone is responding. So please mind that your response is to be sent on this Avanti Fellows co-host. Okay, because I have joined through my mobile also. So I will see your response here. Got it? And this is Avanti Fellows co-host. So you have to send your response to Avanti Fellows co-host. Got it? Everyone, सबको clear है? This is especially to make the session more interactive and more hassle free. ठीक है ना? I'll counting your response on here and teaching you there. ठीक है ना? So let's just get started with it. So good evening, all of you. I welcome you all in this session of electrostatic. And today we are going to learn about the electric field. In the previous case, we have studied about Coulomb's law. But yet we have not able to complete all the topics. So the remaining topic we are going to cover today along with the electric field. Okay, Divyanshu. Got it. ठीक है? So everyone make sure कि there is no lagging between the screen. ठीक है? Everything is visible to you and I'm audible. That is all I want from your side. ठीक है? Okay. So first of all, what is today's aim? Today's aim, first of all, we are going to revise the topic. After that, we are going to see the vector form of Coulomb's law. Got it? This is the topic that we have not covered in the previous class. Okay. After that, we will go through the principle of superposition and electric. Look, this principle of superposition, you can count as a universal law, which is also valid for electric field and also valid for the electrostatic forces. Okay. So no need to worry about it. Clear? Now, so without wasting time, first of all, the very first question that we have learned in the previous class, it is just for your revision, that what is Coulomb's law? So in what manner the force of attraction or repulsion acts between the two charges is given by Coulomb's law. Okay? And that two charges will be a point charge. That is really, really important. What type of that point charge will be? What type of that charges will be? Point charge. Always remember. Okay. Now, here we have 2 point charge, Q1 and Q2. They are separated by a distance R. So we know that the electrostatic forces of attraction or repulsion, which is according to Coulomb's law, is directly proportional to modulus of Q1 and Q2, which is the multiplication of magnitude of charge. And second is F is directly proportional to 1 by R square. Got it? Now, here we have that F is equals to 1 upon 4 pi epsilon naught Q1 Q2 by R square, where epsilon naught is nothing but the permittivity of free space. And I've discussed a lot about the permittivity in the previous session. Okay. The value of permittivity of free space is 8.85 10 raised to the power minus 12 Coulomb square per Newton meter square. Now, this force in terms of direction wise, that like in which direction this force will act, because obviously the force is a vector quantity. So this force acts center to center. Center to center what? The line joining the center of these 2 point charges. The force acts along that line. Okay. Either it is radially away from that line or towards the line. Okay. Towards the center. Clear है सभी को? Now move on to the next page. Yeah. Properties of Coulomb's law that we have discussed in the previous session. Coulomb's law is only applicable to point charge. Enough talk on this topic. Electrostatic force is conservative in nature. So I have discussed it in the previous session. What is a conservative force? So the work done by a force, if initial and final position are same, so work done by a conservative force is 0 always. Okay. So that is why electric force is also termed as conservative. I have already told you that the force which looks like in this nature, F is directly proportional to 1 by R square. That forces are also termed as the conservative forces or conservative field force. Okay. Now, we have seen that there is a term epsilon naught is coming into this expression. Epsilon naught is what? Permittivity of free space. But what if the medium has changed? The permittivity of the medium will change. So that is why we can say that this force depends on medium. So, okay, this force depends on medium. Now it is a central force. So direction wise, it is pretty much clear to you why it is the central force acting center to center. Okay, or line joining the center of two charges. Now it is attractive for opposite charges and repulsive for the same charge. Same charge means positive, positive, negative, negative. Opposite charge means positive and negative. I hope this is clear to you. Now, the next topic that we have covered is force between two charges placed in a medium. So we know that when we have placed these two charges, let's say Q1 and Q2, just a second. Q1 and Q2. Oh my God, just a second. Just a second. Q1 and Q2. So these two charges placed in a medium, let's say of permittivity epsilon, but we do not know the value of epsilon. Epsilon is the permittivity of that particular medium. Suppose we put these charges in oil. Okay. So epsilon is the permittivity of oil. So we can replace this epsilon with K epsilon naught, where K is the relative permittivity or dielectric constant of that material. We will talk about that. What is a dielectric constant? What is dielectric itself? But in the further chapters. Okay. For now, you can only remember that epsilon is the actual permittivity of that particular medium, and this K is the relative permittivity. Okay. So the force for a medium will become F is equals to 1 upon 4 pi epsilon naught K Q1 Q2 by R square. So as you can see here, this force, which is two particles having when they are put inside a medium, any kind of medium, so this force has been reduced from the force that is experienced in vacuum, F vacuum by K. So based on that, we came to a conclusion that the medium is also exerting some kind of forces. Okay, I have explained you in a very detailed manner in the previous class. So here the force by the medium, as you can see here, is F vacuum multiply by 1 minus 1 by K, where K is what? K is the dielectric constant. Okay. So till now, if there any problem to anyone, you can talk to me right away right now. Then any kind of doubt, guys? Okay, you forgot to record the class. No, I'm not recording it anymore because JNV Yanam. Because this class is also going on live on YouTube, so there is no need to record it. Yeah, clear? So till now, if anyone has any kind of problem, you can ask. If this clear to you all, please put a message yes in the chat box. Everyone, waiting for your response to move on. Okay. So let me know, are there any students from Pune region in this class? Are there any student from Pune region? Type yes in the chat box. Okay. So what is the problem now? For Pune region, we are separately running the classes. Okay. For Pune region, we are separately running the classes. So there is another teacher who is waiting for you. Got it? This class is for the Hyderabad region. Got it? There are separate links
Arun,
provided to you for
Arun,
different
for today,
reasons.
Arun, don't for next class the link will be changed. No need to mention. Continue the class. Okay. No worries for today. All the students are here, Pune, Hyderabad, and Shillong. You go ahead with the classes. We'll take care of the operational things. Okay.
Got it. Got it.
Yeah.
Okay, no problem. Okay, so students, stay here in the class. Don't need to go anywhere. Okay. So here, vector form of Coulomb's law. Okay. So vector form of Coulomb's law is very easy. First of all, we have two charges here, Q1 and Q2. You can see here, Q1 is stay at a point A and Q2 is stayed at a point B. Now the vectors, this R1 and R2 vector are the position vector of what? Position vector of point A and position vector of point B, where the charges Q1 and Q2 are placed. Okay. Now understand it line by line. What is R vector? R vector is the displacement vector from A vector to B vector. Sorry, from point A to B. So this is also a triangle law of vector addition. You have must read it in the 11th class. देखो, this is the triangle. Okay. This vector is R1 vector. This is R vector and this is R2 vector. Got it? Now, we can say that R1 vector plus R vector is equals to R2 vector. So here, we can say that R vector is nothing but R2 vector minus R1 vector. Clear है सभी को? Any kind of doubt? कोई doubt नहीं. Here, so R vector is nothing but AB vector is equals to R2 vector minus R1 vector. Why we need to draw this AB vector? We will let you know. So force applied by, since we are talking about the force. So first of all, we talk about the force that is applied by Q1 on Q2. So it is written as the force applied by Q1 on Q2 is F21 vector. Now, if I talk you, if I just ask you about the direction of this force, what it should be? So direction of this force is from Q1 to Q2 because both the charges are of same nature. Okay, and as we have learned in the previous slide that it is a central force, so it acts along the line joining the center of these 2 points. Although here I have taken just a larger space to let you know or understand it in easy way, but the point charge is very short. Okay, it's just like a point. This, got it? But here too, just for the better understanding, I have taken a bigger charge. Okay. So here, this force that is applied by Q1 on Q2 is directed towards the AB vector because this is the vector joining A and B. Okay? So that is why we have calculate this vector. R vector is equals to AB. क्लियर है सभी को? देखो हमेशा फोर्स को इन इलेक्ट्रोस्टैटिक यू विल राइट एज F21. वाई 21? तो जिस पार्टिकल पे फोर्स लग रहा है वो आपको पहले लिखना है, जो पार्टिकल फोर्स लगा रहा है उसे बाद में लिखना है, ठीक है? सो हियर F21 इज व्हाट? फोर्स अप्लाइड ऑन पार्टिकल 2 बाई 1, ठीक है? So we can say that F21 vector is equals to KQ1 Q2 by R square. अब KQ1 Q2 by R square तक तो सभी को क्लियर है कि we write the force as the product of magnitude of two charges divided by the separation between them का square. So here, if it is a vector, we are representing it in the form of vector. So we have to make the direction vector also. So we have taken R cap because force is applying in the direction of R vector. So we have taken the direction vector of this R. Now, how to calculate the direction vector? So it is very simple. You have to take up the vector divided by its magnitude. Then the next line we have did the same. F21 vector is what? KQ1 Q2 by R square. R vector divided by modulus of R vector. Now, magnitude of R vector, as you can see here, the R vector ka magnitude is R, which is also can be written as R2 vector minus R1. So this will become R square into R will become R cube. So F21 is equals to KQ1 Q2 by R cube into R vector. It's totally up your choice. You want to remember this formula or this formula. Both are valid. Okay. Now similarly, if the force is applied by this Q2 on Q1, we will write it as F12. As you can see, when this Q2 applied the force on Q1, the direction of force will just reverse. Or simply you can say the direction of displacement vector will reverse. Now the displacement vector R vector dash will become PA vector, which is nothing but minus of R vector. So that is why I have written it as F21 vector is nothing but F12 vector is nothing but minus of F21 vector. Got it? And it is according to the Newton's third law. Every action has an equal and opposite reaction. So it is satisfying the Newton's third laws. Clear है सभी को? Anyone, any kind of doubt? Let me know in the chat box. Now, based on this concept that we have covered so far, or just now, there is a question here. So a positive charge capital Q is placed at AO. AO is a point, and another point charge Q is placed at OA. OA, I am saying O, which is likely to be 0. Okay. Find the force on Q. So you have to find the force on this. Okay. Anyone ready? So make sure the vector form is clear to you. Okay. So look here. This is the point. This is also termed as origin. Let me change the color here. So this is origin 0, 0. Okay. This is Q. This is capital Q. Now this is very simple. You can find it out that what is force. Force is K Q1 Q2 upon R square, where R is the distance between two charges. So this charge is present at A0. This charge is present at 0. But what is the distance in between them? You can calculate. This is nothing but, let's say R. Here is nothing but, this you can say x1, y1. This you can say x2, y. Got it? Now, you will calculate this R vector is equals to what? The distance between 2 points. So it is x2 minus x1, a minus 0 whole square plus 0 minus a whole square. Got it? So R here is nothing but root 2. So you can say that magnitude of this force is nothing but K Q1 Q2 upon R square. R square we have already calculated. R we have calculated root 2a ka square. So it will become K capital Q small q divided by 2a square. But this is the magnitude. Say one wants the answer in the form of vector. So how you are going to do it? So in the previous case, we have seen that to write the magnitude, write the force in a vector form, you need the direction vector. You need the direction vector of displacement between 2 point charges. So we want the force that is applied by capital Q on Q. So direction of force will be in this direction. Okay. Let's say this point is A, this point is B. So direction of force will be AB vector. So you need to calculate AB cap. AB cap will become AB vector divided by magnitude of AB vector. Now listen to me carefully here. What is the magnitude of AB vector? Isn't it the R that we have calculated? R is nothing but the magnitude of AB vector. ठीक है? Got it? Clear है सभी को? Now, what is R vector then? Or AB vector? Because AB vector ko I can write at R vector. So for that you need to recall your vector knowledge. So R vector you can write as, we know that X I cap plus Y J cap. So you need to put the X coordinate, which is specifically X2 minus X1, I cap plus Y2 minus Y1, J cap. अब देखो X2 minus X1 करेंगे अगेन, तो 0 minus A minus AI cap plus A J cap. ठीक है? So put it here that F vector is nothing but K capital Q small q divided by 2a square R square, and you need to put what? You need to put R cap. R cap is what? R vector divided by the magnitude of the vector. R vector is what? Minus AI cap plus A J cap divided by magnitude of this vector is what? Root 2 times A. This, again, what you can do, you can take A as common. So K capital Q small q divided by 2A square into minus 1 upon root 2 I cap plus 1 upon root 2 J cap. Clear है सभी को? So this is the formula for, this is the expression for force in vector. Clear है? सबको clear है? Everyone? Make yes and no. Very good, Shridev. I think lots of students are here. So please put yes or no based on your understanding of this question. Clear है? All of you? Okay. Okay. Suraj, ENV, Yanam, Shridev. What about you, JNV Kolhapur students? Sneha, what you are saying? Acha, revise once. No problem. देखो, it's very simple. What you need to calculate the force in vector form? The magnitude of the force and the direction vector. Direction vector, how you will get? You need to join the two charges, and that line is nothing but the direction vector. Okay? So we know that if Q is apply the force on Q, it will be away from the, because both the charges are same. So there will be a repulsive force. So Q try to be move away. So that is why the direction is towards Q. Okay? This is the line joining. So we have calculated that force is nothing but K Q1 Q2 by R square. K Q1 Q2 by R square. Now, Q1, Q2 is nothing but capital Q, small q. R square is nothing but the distance between them. So this is a triangle, you can say. This length is nothing but A. This length is nothing but A. So perpendicular and base are A. So hypotenuse will become root 2A. So simple. So we have calculated the magnitude of force. Now to calculate the direction, okay, we need the direction vector from my capital Q to small q. So these two coordinates are given to us. We can also write the vector. So vector को लिखने के लिए, displacement vector को लिखने के लिए, what we do? x2 minus x1 I cap, y2 minus y1 j cap, plus z2 minus z1 k cap. But here we are talking about only two dimension, y-axis and x-axis. So we have taken two coordinate only. x1, y1 and x2, y2 is already given to you. So you can calculate. Now, when you have calculated r vector, to make it a unit vector or direction vector, what you will do? r वेक्टर को यूनिट वेक्टर बनाना है तो क्या करेंगे? इसी के मैग्नीट्यूड से डिवाइड कर. मैग्नीट्यूड इज नथिंग बट द मैग्नीट्यूड ऑफ दिस लाइन. ठीक है, एंड दैट इज रूट 2. सो वो सेम आई हैव टू डू. क्लियर है सभी? एवरीवन? स्नेहा, नाउ इट इज क्लियर टू यू?
Yes, sir.
Okay, you can also verify कि why this component is being negative, because when you say this, the force on small q na, it will be acting in this direction. So when you resolve it into two component, one component will come in x direction and one component will be fy direction. So this is upward, y direction is upward, positive, so fy is positive. That is why this component is being positive. But fx, if you will see, it is in the negative x direction. That is why this is coming as minus 1 by root 2 I cap. Okay. Now, I want you to do this question in a similar manner, but you need to calculate force by small q to capital Q. ठीक है, यहाँ पे हमने क्या फाइंड आउट किया? व्हाट वी हैव फाइंड आउट हियर? फाइंड द फोर्स एक्टिंग ऑन Q. यू हैव टू फाइंड द फोर्स एक्टिंग ऑन कैपिटल Q. सो दिस इज योर होमवर्क. होमवर्क कर लोगे सब? एवरीवन? इजी फॉर यू? इट्स अ इजी पीजी वन ना? सो होमवर्क अब सबको नोट कर लेना है. दिस इज योर होमवर्क. You need to calculate the force in vector form on capital Q. ठीक है? Okay. Now, this is the bonus concept for you guys. So when two bodies are charged with different magnitudes means different magnitude of charge. Got it? So they are brought in contact after touching each other at the same distance. What will be the final charge on each body? So these are the two charge bodies. Okay, say Q1 and Q2. This is before. Okay, they have charges Q1 and Q. At the same, after some situation, they made to touch each other. Okay, this is the point of contact. Okay, after that we have kept it on the same distance. अभी यहां से लेकर आया था दोनों चार्जेस, टच कराया, वापस यहीं पे रख. So same distance पे we have charge. Got it? So what will be the final charge? What will be the final charge? The final charge will be, always remember, if Q1 is greater than Q2, charge will flow from positive charge or let's say higher charge to the lower charge. Got it? So suppose Q1 Q value is given to you as 10 coulomb and Q2 is given to you as 5 coulomb, or let's say 4 coulomb. So when they touch each other, the charge will flow from 10 coulomb to 4 coulomb, because 10 is higher value. So charge, जैसे pressure will flow from higher pressure to lower pressure, ठीक है, water will flow from higher altitude to lower altitude. So same way में charge will also flow from higher value of charge to the lower value of charge. So it will flow this until we have same charge on both bodies. ठीक है, इसके बाद वाला तो चार्ज कब तक फ्लो करेगा? व्हेन विल द चार्ज विल फ्लो? ऑलवेज अप टू विच लिमिट? व्हेन द बोथ चार्जेस विल बिकम equal. It's similar to you can keep this in mind. Suppose we have two beakers, one of is this much filled, one of is this much filled with the liquid. So your task is to maintain the same height. Okay, so this will flow up to, let's say, here, when both the beakers have same amount of liquid. Got it, everyone? So can you tell anyone what will be the final charge if Q1 is 10 coulomb and Q2 is 4 coulomb?
5 coulomb, 5 coulomb.
5 coulomb for both. Answer in the chat box. देखो 10 से ये 9 होगा तो ये 5 होगा, ये 8 होगा तो ये क्या होगा? 6 होगा, उसके बाद ये 7 होगा तो ये भी 7. अब इस 7 के बाद देयर विल बी नो फ्लो ऑफ चार्ज. ठीक है, इसके लिए सिंपल ट्रिक क्या कर सकते हैं? यू टेक बोथ द चार्जेस, add them and divided by 2. So it will be Q1 plus Q2 divided by on both the sphere. क्लियर है? तो ये क्वेश्चन आप करके दिखाओ अभी. राइट नाउ यू हैव टू डू द वर्क. सपोज this is a sphere and it has a charge as 10 coulomb, and this is another sphere which has a charge at minus 4 coulomb. So what will be the final charge when they meet to touch each other and they are separated after that? What is the final charge at that time? Everyone, very good, Sneha. Just use the concept that I have taught you. You can also do it in the tabular form. Here you made 10, here you made minus 4. So यहाँ से एक जाएगा, it will become minus 3. What is minus 4 is doing? Minus 4 is both. It is accepting the positive charge. Then it will become minus 2, minus 1. Similarly, it will become 9, 8, 7. After that, it will become 0 here. It will become 6 here. Then it will become 1, 5, 4, 2, 3, 3. But this is very lengthy. So why not use very simple one? So you can do what? Take the sum of two charges, 10 minus 4, along with sign. Along with sign you have to take, divided by 2. So it is 6 by 2, which is, so 3 coulomb on this, 3 coulomb on this. Clear? Okay, very good. Very few answers are given by you. Have you guys any problem understanding the concept? Everyone? You guys are having problem with the concept. ठीक है. So try to answer all of you. I especially joined with my mobile to show, to see your responses. Okay. Okay. Now just list. This is another question. So try to solve it. It is just based on the previous concept that I have. Try to solve it. If two identical sphere having charge 16 coulomb and minus 8 coulomb are kept at certain distance apart, then the force is F. Okay? They are touched and again kept at the same distance. The force become what? F, F by 4, F by 8, F by 2. JNV Kolhapur, you are not responding. Are you not attending the session? Let me check how many guys are here and answering. See, Anil is also here. Anusha is also here. Apurva, Bhagat, Bharat, Uvam, Jeevan, JNV Anand. There are lots of students, but response is not from the lots of students. Okay. Make sure that you give the response also. So I'm giving you 1 minute to solve this question. Everyone. And try to give you an answer in terms of this number. Option 1, option 2, option 3, or option. Come on, hurry up, guys. It's very simple, by the way. So here, see, let me just solve it. If you guys are solving it, try to solve it. Okay, Sneha has answered. Okay, okay. Let me see. 16 and minus 8. Okay, let's say the separation between them is small. So initially, when they are not being touched, the forces is what? K 16 into minus 8 divided by what? R square. Since we are talking about only about the magnitude, so we can neglect this minus sign. So it will be K into 16 into 8 upon R square. Okay. When they've been touched to each other, the charge will flow from 16 coulomb to the minus 8, and they will have 4 and 4 coulomb according to the concept. So finally, they are being 4 coulomb and 4 coulomb. Separation we are not changing. Separation is R itself. So force here, let's say F1 I'm saying, will become K 4 into 4 divided by R square. Now if you take the ratio, F upon F1 is what? 16 into 8 divided by 4 into 4. This will cancel out this. So we can say that F1 will become F upon 8. So correct option is option 3. Okay. Sneha, check your answer. Maybe some mistakes that you have made. Okay. So is it clear to everyone? Yes, no? Everyone, please respond in the chat box, or you can unmute yourself and then see. Okay, okay, very good, very good. Got it. So I think that you have got the concept. Now, here the topic that we are going to cover is electric field. Now, I just want you to wonder that if this is a charge, let's say Q1, and if there is another charge, let's say Q2, they are being separated by a distance, let's say smaller. So this Q1 is apply the force on Q2, this Q2 will apply the force on Q1. There is no doubt in that. There is F, which is K Q1 Q2 upon R. No doubt at all. Suppose there is a table and a book is placed on that table. So we know that this book is applying a force, that is gravitational force due to its weight, to the table, and table is applying a normal reaction. When you are outside the house or on the road, you are moving in this direction, you are pushing the earth in the opposite direction, so earth will push you in the direction you want to move. And this is because of the friction. So when we talk about the frictional force or the normal force, now these forces are due to the contact force. Without even making a contact, you cannot experience friction. You cannot experience the normal force. Is it possible? Without contact, you are experiencing friction? Not at all. So you have to make the contact. At that time, friction will come into the picture. Got it? But we can see here, if I just talk about the gravitational force, suppose this is the surface or earth, and here we have a ball of mass m. So there is mg force is also acting at that point. Although the point to note here is that there is no direct contact between earth and the mass particle. So why this force is being acting? How the gravity is acting to that particle? So that we have discussed in the gravitation chapter. In the same way, if you will see here, this Q1 charge is at certain separation from Q2, and it is exerting a force to this particle Q. Suppose I have removed this particle. There is no Q2 here. Now, have you seen any forces acting on that place right now? There is nothing. There is nothing at this place. But as soon as I put some particle here, the forces start acting on this. So I think there is some point of some kind of hidden gems here that is applying the force on Q. Or that hidden genius or that hidden gems is termed as the electric field. Got it? So what is happening according to the physicist, how the electric field is working? Suppose this is Q1, it's a charged particle Q1. So what physicist has suggested is this Q1 has created an electric field or a field around it. Got it? Let's say a foreign particle or another charged particle Q2. If this charged particle Q2 came into that field, it will experiencing a force due to it. So what is happening? This Q1 is executing a field, and that field is applying the force on the other particle if they are in the range. Got it? So this is what it is happening. That is why the concept of field has been alive, because there is no direct contact. So somehow we have to satisfy this, how this force is acting to that particular particle. So we can say that the charge particle, each and every isolated charge particle creates its field in the space, that is electric field, that applied the force on the other particle. Clear? I think this is clear to all. Now, always remember when we say field, every time, either it is gravitational field, potential field, or electric field, or magnetic field, is a quantity which depends on the position vector in space, or you can say that this is space dependent. Space dependent means it depends on where the particle has been in that particular picture. So suppose this is Q1, which is creating its field, and there is a particle Q1 is here, sorry, Q2 is here, and if Q2 is here, so there will be different field or different force acting on the same particle. So that is why always remember that field, if I say field, this is the quantity which depends on the position or the space dependent quantity. Clear? I think this is clear to you all. This point को you will take as a note in your note. Okay? Okay. So now read this definition aloud. When a charge is brought closer to the another fixed charge, then it experiences some force, I have already discussed, on it due to the presence of the fixed charge. This reason, in the surrounding of a charge where any other charge experiencing a force is called the electric field. The same we have discussed earlier. There is no need to more discussion on that. Only thing that you need to remember that through which particle you are calculating the field. Suppose you are seeing the field for Q1, so this Q1 need to be fixed. Only this condition you need to follow. So particle, whatever the particle you have chosen for the electric field, that particle must be fixed. Got it? Now, this is a what? A vector quantity with the same direction as the electric, because although electric field is a consequence of electric force, so it is a vector quantity. So it will experience in the same direction in which the force is applied. Okay? In other words, you can say that an electric field is the space surrounding electric charge capital Q, in which another charge small q experiencing an electrostatic force of attraction or repulsion. Okay? So electric field is nothing but a space surrounding an electric charge capital Q, in which another charge small q will feel a force, either it is attraction or repulsion, based on the sign of the charge or the type of the charge. Clear? Now, every charge particle creates an electric field unaffected by the other charge. So suppose there are multiple charges in the system, each and every one creates its own field, and that field is unaffected by the other charge, whatever the number of charges are present. Okay. This is somehow called as the principle of superposition. Got it? Now, electric field due to a point charge. This is very initial of the electric field. Okay. So suppose we have a charge here that is capital Q. Sorry. Let's say capital Q. And here we have a charge small q. So we will start with what is the force here. If this is r vector, so we can say that force here is k capital Q small q divided by r square into r cap. There is no problem in this expression to anyone, I think, because this is a simple force I have applied. This is a Coulomb's law. Kq q1 q2 by r square into r cap. Okay. Now, what is if I calculate force divided by this small q is equals to what? K capital Q by r square into r cap. And this is nothing but the electric, which is K capital Q by r square into r cap. Now you need to understand this. If I need to calculate this charge particle here is unit test charge particle. So what is unit test charge particle? Unit test charge particle. So we have chosen this charge particle Q naught, let's say Q naught here, in such a way that it has negligible electric field. Okay. Electric field is just the measure of intensity of force which a particle can apply on the other charge particle. So suppose here this q naught is not a test charge particle, it is something having a smaller value of charge, but it is having a charge. So the electric field that is generated by this capital Q, we are not able to calculate it fully, because this electric field will be disturbed by the charge particle, because at that time it is also making its own electric field. So that is why we have chosen such a particle, such a charge particle, which has negligible electric field, and that particle is termed as what? Unit test charge particle. So here, if you can see that electric field is nothing but limit q tends to 0 f vector divided by q. And when q is 0, if q will become 0, so this force will also become 0, approximately 0. So which means that you are only having the value of electric field there. Okay. Got it? So this electric field is also defined as the unit force applied by a charge particle on a unit test charge particle. So you can say here, this electric field is nothing but force applied on a charge unit test charge particle. Got it? Clear है सभी को? Anyone any kind of doubt in this? Okay, please repeat the last point. देखो, we need to calculate the electric field due to point charge. So what we have discussed, that there is a point charge capital Q. इसकी वजह से at point P पे we need to calculate the electric field. So we have assumed a charge particle here. Initially it is not a test charge particle. Initially is just a charge particle. So this is the Coulomb's law of attraction or repulsion, because both the charge are same. So it will become K capital Q small q by R square into R. This is the force. Now, according to the definition of electric field, is what? Electric field is the space surrounding an electric charge capital Q in which another charge Q experience an electrostatic force of attraction or repulsion. And this small q is nothing but unit test charge. Okay. So that is why, okay, that limit part is also. So this electric field is nothing but force per unit charge. It is similar to that. If you want to buy 10 bananas, so you need to know the cost of one banana, and that is called the rate. So suppose one banana is of 15 rupees. So what is the cost of this 10 banana? So you have to multiply it 10 into 15. Got it? Clear as it? 10 banana is of 150 rupees. Now what is the cost of one banana? It will be 150 by 10. And that is nothing but electric field also. Electric field is also the force applied on a test charge particle, on a unit charge particle. Force per unit charge. Similarly here, number divided by the unity of that price. Clear? Now, that limit wala portion is also here. Focus on this part. So suppose why we are limiting it to q tends to 0? Because q is any charge particle which can create its own field, and that field will disturb the field of this point charge that we are interested in. Got it? So that is why we are putting this charge to be very, very, very less value, very, very less value. That is unit test positive charge. तो टेस्ट चार्ज होता है, that charge is negligible. क्योंकि कोई भी चार्ज negligible field कब बनाएगा? When it has negligible value of charge itself. So that is why we are limiting q tends to be 0. But यहाँ पे कोई सोच सकता है क्या कि if q is tends to 0, then this electric field will be infinite. No, it will be a finite value because f is also proportional to small q. So जैसे जैसे q will decrease, वैसे वैसे f will also decrease. ठीक है? So ultimately you are having a finite value. Got it? So if I just ask you, what is the force applied? Force applied by capital Q on Q naught. So it will be given as Q naught. You have to take that charge on which the force you want to see, multiply by electric field of this capital. Okay? So this is very important formula, very important relation you need to remember. Clear? So you have to take the field of that particle. Obviously, you have to take the field of that particle in which another particle has been come. Okay? Because that field is going to repel or attract the another charge particle. In this situation, the field created by capital Q is responsible for the force na, on this Q naught. Okay? I hope this is clear to you, electric field. Now, the principle of superposition. Clear है ना सभी को? Any kind of doubt in this electric field? Everyone has to answer. Everyone. So principle of superposition is what? Principle of superposition states that the electric field due to separate charge distributions adds up vectorical, which means let's say we have Q1, Q2, Q3, Q4. Okay, these are four charge particles, and here is the test charge particle we are saying. Okay, so what is the force applied by these charge particles on this Q naught can be vectorically add up. So this is the principle of superposition. Okay, so the net force of a system is given by the individual force ka vector sum vector sum of individual forces. So Q2 will apply the force, Q1 will apply the force, Q3, Q4. So it is same as 0, 1, 0, 2, 0, 3. If we divide it with Q naught, what it will become? F by Q naught, what it will become? Electric field. So this is the electric field of this particle because we have divided the force applied by this particle by this test charge. Again, F02 divided by Q naught. So we have divided the force applied by the Q2 divided by this unit charge, test charge. So this will become what? E1, this is E2, this is E. Remember that this is not an algebraic sum, this is a vector sum. So you need to be very careful about the directions also. Got it? Now, based on that concept, this is the question. Calculate the electric field intensity at O in each of the case. O is the center point, and each vertices has plus Q charge. Try to calculate it for the line, for this line. Calculate karo. What is the value of electric field at point O? Suppose ये वाली जो distance है ये भी r है, and this distance is also small r. What is the electric field? Everyone. तो इस केस के लिए मैं करके दिखाता हूं आपको. देखो इलेक्ट्रिक फील्ड कैसे लिखनी है? K for this point charge, KQ upon at which distance it is been asking up to from here to at distance r, so r square. ठीक है, at this point it is asking ना point O. ठीक है, point O तक what is the distance r square and what it will is the direction also. So direction is also radially outward. ठीक है, so for positive charge always remember the field is radially outward. For negative charge it is radially inward. Got it? So this direction is also in this direction. Let's say here by this positive charge the direction will be opposite, but the magnitude is same. Magnitude is same and direction is opposite. So what will be the net? E net. E net is what? We have seen that according to principle of superposition, they will have to add up according to vector addition. So suppose this is vector A and this is vector B. So what is the vector sum of these? So C vector is nothing but A vector minus B vector का B vector. ठीक है. So which one is greater? You have to put accordingly. But यहाँ पे E1 vector और E2 vector is what? Same. So that is why net electric field is 0. Clear है सभी को? Everyone? Clear है? Come on guys, you all have to answer. This is for you, not for me. What is the answer in this case? Tell me. What is the answer in this case? In this triangular case, second one. What is the answer? What is the answer? In triangle case also. So in this case, this distance is same. This is also same. This is also same. Distance is same and they are being in this direction. One of the component will in this direction, one of in this direction. Similarly, this component will cancel out this one. This will also have in this direction. This is a kind of mathematical work that is being. I will tell you a trick. What is that trick? If the angle between two adjacent electric field vector is a multiple of or not the electric field vector. If the angle between two vertices, angle between two, we can also do it in the terms of electric field vector, but for your better understanding, if the angle between two adjacent vertices is a multiple of what? 2 pi by n, then electric field or any vector sum at center will be 0. अब देखो 2 पाई बाई एन को क्या लिख सकते हैं? 2 इंटू 180 डिवाइडेड बाई एन विच इज 360 बाई एन. यहाँ पे वर्टाइसिस कितनी है? यहाँ पे साइड्स कितनी है? 1 2 3 4. 4 वर्टाइसिस है. ठीक है. एन इज 4, so it is completely divisible or not? Yes, it is completely divisible. So at the center, any two vertices that is being joined, at the center, the field is electric field vector is 0. At this case also, calculate the number of vertices. 1, 2, 3, 4, 5, 6. 6 divided 360 divided by 6. Again, it is a what? Multiple of 360 by n. So here is also electric field is 0. But you have to remember it is only the case when charge distribution is also same. Same charge is being distributed. Same charge is being distributed. ठीक है? क्लियर है? नाउ इस केस में बताओ, थर्ड ज्योमेट्री में बता रहा हूं सब. एवरीवन, what is the value of electric field at this point, at the center? At this value, everyone, only 1 2 responses I have, out of which, out of 28. Everyone, tell me the answer. So always remember, if the number of vertices is a multiple of 2 pi by n, or 2 pi by n is completely divided with the number of vertices and charge distribution is also same, at that point of time, at the center, the electric field will be zero. Okay? So in this case also electric field is zero. Clear? Clear everyone? Now you need to do a question that if this is the equilateral triangle, यहाँ पे पॉजिटिव पॉजिटिव चार्ज डिस्ट्रीब्यूटेड है. So what is the force on this charge? Charge number 3. This is 1, this is 2. So what is the force on this charge by these two another charge? We need to calculate this. Till now, if anyone has any kind of doubt, you can ask. Otherwise, the lecture is being over. This is homework. Any kind of doubt, guys? समझ में आया सभी को? Everyone is clear with the concept? So you can rate this lecture out of 0 to 5. 5 is the best, 0 is the worst. So give the rating here in the chat box. Thank you so much, guys, for attending this lecture. Bye. Take care.